Hello students, how are you? I hope you are doing well and just preparing for your exams, JEE mains. So keep going, okay? Don't get disheartened if you are not able to solve questions or if you are not getting answers. It's a part of our life. Okay, everybody learn by committing mistakes only. Okay, so that's a part of life. So you shouldn't worry about that, but you should not let it go. Okay, so keep working hard, keep struggling, and be positively oriented. Okay, and have faith in the Almighty. Right. So we'll start. Today I came with two questions based on electrostatics. This has been picked from the morning shift, 24th January 2023, JEE mains exams. So let us start. The first question is, if two charges Q1 Q2 are separated with distance d and placed in a medium of a dielectric constant K, what will be the equivalent distance between the charges in air for the same electrostatic force? So we have two charges Q1 and Q2 separated by distance d in a certain medium with dielectric constant K. So therefore the force between them, force in the medium, you know it is 1 by 4 pi epsilon. Epsilon will be what? Epsilon 0 into epsilon r. So this is the complete constant into product of the charges upon square of separation between them. Now we have to find the equivalent distance between charges in air for the same electrostatic force. So let us say that the new distance is d dash in air or vacuum. Okay, both the charges have been shifted to a new distance. Now this force in air will be simply 1 by 4 pi epsilon 0, because for air we take epsilon as epsilon 0. The charges remain same, but the separation has now changed to d dash. So as per the question, both the forces must be same. That is, force in the medium should be equal to force between the charges in air. So when we equate them, we will find that k d square is equal to d dash square. So therefore, extracting the square root, you have d dash is equal to d root over k. So correct option is the first option. As you can see, since k is more than 1, so root k is also more than 1. So d dash is greater than d. So we have to increase the separation. In order to have the same force between a pair of charges as that in the medium, the corresponding separation in air should be more. So remember this. Let us move to the next question. So the next question is, a stream of the positively charged particles having q by m equal to this. Remember, this is the power. This power 10 is power coulomb per kg, and velocity of this much is deflected by an electric field of this much. The electric field exists in a region of 10 cm along x-axis. So first thing to note is that velocity is along x-axis and the electric field is along y-axis. So let us draw a diagram. Due to the electric field, the deflection of charged particles in the y direction is. So I would like to draw a diagram, rough diagram. Okay. So this is x-axis, this is y-axis. The electric field is along y-axis over a length of how much? Over a length of 10 cm. Over a length of 10 cm. So here a charged particles arise along x-axis because its velocity is along x-axis. You can see the moment it enters the electric field, it starts experiencing a force in the positive y direction, that is in the direction of electric field. So naturally it will get deflected like this, and as it emerges out it will fly away tangentially. So this deflection can be measured in terms of this angle. or this distance. In the absence of the deflection, the particle would have emerged at this point. Yes or no? The particle would have emerged like this, but because of this deflection, it is emerging like this. So this linear distance they are asking, because they are asking in mm. So this we have to find, this distance. This distance we have to find. Okay. So here it is experiencing, within the electric field, it experiences a force. That force results in an acceleration, and that acceleration results in a velocity. So it is gaining velocity along the y direction as it moves through the electric field. That is the reason it is getting deflected. So this deflection, linear deflection, can be obtained by using this formula ut plus half a t square, because after all the acceleration is constant. So we are using the equation of motion. So we have to know the acceleration and we have to know the time. Is it? So let us calculate the time. Now along the initial direction of velocity, the speed remains same, because anyway force is acting along y-axis. So along the x-axis, considering the motion along the x-axis, we can write that the time elapsed will be distance by speed, since it is traveling with a constant speed along x-axis. So distance covered will be 10 cm. 10 cm means converted into meters, and speed is 3 into 10 power 7. So 3 into 10 to the power 7 meters per second. So the required time will be how much? 1 upon 3 into 10 to the power 8 seconds. This is the time it takes to cross the electric field. Now meanwhile, how much is the displacement along y-axis? Also we have to find the acceleration. So acceleration you can find as force by mass. Force experienced by charged particle within an electric field is QE. So QE by m. So what is QE? Q is how much? Charged particle. So Q by m is already given as 2 into 10 to the power 11 SI. Its electric field is numerically equal to 1.8 into 10 power 3. Remember kilo, K stands for kilo. So 1800 I will write in SI unit. So this will be 2 into 18 into 10 to the power 30. So I will write it here. Half A. A is 2 into 18 into 10 to the power 30 into T square. T is this. So 1 by 3 into 10 to the power 8 whole square. Okay. So 3 is a 9. This is 2. 13 minus 16 is how much? Minus 3 meter. So this is 2 mm. So the correct answer is 2. Are you getting the point? So I hope you enjoyed this solution. Please subscribe my channel and also hit the like button. Please refer to your friends and relatives. Okay. Thank you so much.